Hello, welcome back. Today, we'll talk a bit about simplifying trig expressions. So we want to understand some basic identities, okay, relationships, and then also about how to use them to simplify, work on kind of practicing simplifying trig expressions. So first, let's talk about some basic identities. And an identity is something that's true for every number within some range, okay, within some domain. So think about some of the basic identities, the ones you're already familiar with. For example, the cosecant, think about cosecant of theta or x, or whatever variable you want to use, is 1 over sine. And remember that goes both ways. So sine is also 1 over cosecant. Okay. Then secant of theta is 1 over cosine. Once again, that one also goes both ways. The cosine is also 1 over or 1 over secant. And then finally, cotangent of theta is the same as 1 over tangent. So those are some basic identities you're already familiar with. A couple more that you are hopefully familiar with is that tangent of theta is sine over cosine. So it's sine of theta over cosine of theta. And cotangent, of course, being the reciprocal of tangent, is cosine of theta over sine of theta. Okay. So what makes these identities is these are true. These are equations, but they're not just simply true for like a value or two. They're true for essentially any value that within the certain domain. For example, this is true as long as sine is not 0, because if it was, 1 over 0 would be undefined. As long as that's not the case, this is true for any other values where it doesn't make it undefined. Okay, these are identities. These are always true. Okay, now a few new identities you may have seen before or maybe not, or some called the Pythagorean identities. Okay, this is kind of the most famous one. Says that sine squared of theta plus cosine squared of theta equals 1. This is also identity. So actually, since sine and cosine are defined for any values, this is true for any theta you can imagine, anything you can plug in. Okay. And actually, then from this, we can actually get these two other additional Pythagorean identities. One relating tangent and secant, the other relating cotangent and cosecant. Okay. And these, once again, these are identities. So as long as whatever thetas are in the domain, it's true for all those values. Now, what we want to practice with today are just kind of working with some of these basic identities and others, just practicing working with skills you need some to simplify trig expressions. Now, in simplifying and also in what's called verifying an identity, there's often more than one correct approach. There's often more than one way you can do it. So, and sometimes, a lot of times, just comes to practice determining what the easiest or best approach is. Now, if you have a kind of a complicated expression, it's often helpful to add, subtract, multiply, or divide. Sometimes you get a simpler expression, or even factor. We can also factor to get a simpler expression. And we'll see some examples of that. Also, we want to consider using identities to simplify. These identities here are also made these Pythagorean ones. And then as we learn more identities, also use other identities to simplify the expression as well. And then finally, we can always try changing in sines and cosines, but often that's not the best thing to do at first. But that's something we can always try to do to help make things simpler. So let's look at some examples on the right. And here, on directions, I'll just say simplify. And simplify doesn't always have the easiest meaning here, but sometimes what you get may not necessarily be that much simpler, but just involving practicing working with these. Let's take a look at number 1. Oops, sorry about that. Jump to the bottom. So number 1, let's say we have the tangent of x times the cosine of x minus the cosecant of x. Okay, now this one, so we want to think about how we can go about doing this. All right, now one thing we can go ahead and change into sines and cosines. We could change tangent into cosecant into sines and cosines. But that's not necessarily the best thing to do first. We could also look if we have any identities relating to these things together. If there's an identity related cosine and cosecant, we can potentially use that. There isn't one available, but one that I know easily. So the best thing I think to do here is actually just multiply. We're going to distribute. Then go from there. So tangent times cosine is just tangent of x times the cosine of x for now. Okay. Then since we have a minus here, minus, then tangent times cosecant. Okay. Now, at first, that doesn't really do much for us. Okay. So let's actually write this now using sines and cosines. Okay. Put everything in terms of sines and cosines. Let's see if that helps. So tangent, as we said, is sine over cosine. So sine of x over the cosine of x. Okay. And once again, of course, over here, again, tangent is sine over cosine. And of course, cosecant is 1 over sine of x. Okay, so now this does help us because now we see we can cancel some things out. If we multiply this across, we'd have cosine over cosine, which cancels out. The sphere, we're left with just sine of x. Okay, over here, we could actually cancel out the sines, and so we'll be left with 1 over cosine of x. Okay, now let's also write this. One more thing we can do is actually write this in terms of 1 over cosine, which is secant. Let's get rid of the denominator. So we have the sine of x minus the secant of x. Okay. And now I have something that's simplified compared to that. Not necessarily a whole lot, but it's simpler. Okay. If you think about it in terms of how many things we have to do here, this one actually requires 3 different operations. Okay. Computing the sine, calculating the sine, the secant, and then subtracting them. And this one actually has 4. So we have to do those same 3 for here, cosine, cosecant, and subtract them, and then multiplying by tangent. So this is actually a simpler expression. Okay. Number 2. So what if we have this? So in parentheses, 1 plus the tangent of x squared. Okay. Now, one thing we have to be clear about, this is not equal to 1 squared plus tangent of x squared. Okay. Unfortunately, it doesn't work that way. It would be simpler, but it's not the case. So you can't distribute a power. What this is equal to is we have to do essentially, just like x squared means x times x, this we have to write it twice. It's the same as 1 plus the tangent of x times 1 plus the tangent of x. And then we can multiply that. Okay. In fact, here what we're going to do here is FOIL, just like we do with a binomial. Okay. For f means first, so our first terms, 1 times 1 is 1. Our outer terms, or outside terms, 1 and positive tangent x is just tangent of x. Okay. The inner one turns out to be the same thing for this one. Positive tangent x times positive 1 is plus the tangent of x. And then finally, the last one, tangent of x times itself is plus tangent squared of x. Okay. Now, let's simplify this a bit. All right. So I combine these two. These are like terms. I combine the two in the middle. Actually, I'm going to write this a bit differently. So I'm actually going to put the tangent first. So the tangent squared next. Okay. Then plus 2 times the tangent of x. Okay. Once again, these are like terms. So I combine them here. If you notice, take a look at this. 1 plus tangent squared. We can actually use one of our identities here. This identity says that's the same as secant squared. This is secant squared of x. And so this becomes secant squared x plus 2 times the tangent of x. Okay. Now, I can argue whether it's actually that much simpler, but is what we're doing here, our goal is mainly just to practice working with trig expressions and different operations, adding, subtracting, multiplying, dividing them, and also just trying to work with them in that way. So in that case, if we got something important out of this is being able to see then how we could simplify this. Okay. Or at least convert it to a different form. Okay. Number 3. This time, let's say we have this. Let's say we have cosine squared theta minus cosine theta minus 6. Okay. Now, in this case, we do have a Pythagorean identity here that relates sine to cosine, but that isn't really necessarily, since it's not obvious, that's helpful, because changing that to involving sine doesn't necessarily make it easier. Here, and also here, we're already in terms of sines and cosines, so we can't really do that. What we can do, though, is potentially we can factor this. Now, what we're also going to do is something called a U substitution. This is something that's often you'll see in calculus, which is useful. To use what's called a U substitution. Okay, and what that means, I'm going to let U is equal to just the cosine of theta. Now, this is entirely necessary, but it's something to practice. It's something if you take a calculus class, you will see in there for different ways. Okay, so what we're going to do then is wherever I see a cosine, I'm going to replace it with U. All right, and so this is going to be equal to, obviously here, this is going to be U. Okay, here I have cosine squared. I mean that the notation means we have cosine of theta squared. That's the same as U squared. Okay, and of course cosine is U, so U squared minus U minus 6. Okay, now if we factor this, and depending on what we've seen factoring before, so this is kind of like a FOIL in reverse. So to get a U here, U squared here, you have to have U here and U here. Okay. And then one thing about our last terms that come from here, so the possibilities to get a 6 is either 1 and 6 or 2 and 3. And since this is negative, it means you have opposite signs. So it turns out it's going to be U minus 3 and U plus 2. And if you FOIL that, if you check it, you'll see that. Okay. Now what we want to do is simply want to substitute back. Oops. Let's see. Okay. So when you substitute back means where we see a U, then now put a cosine. And so this becomes cosine of theta minus 3 and cosine of theta plus 2. Now, this isn't necessarily simpler. What we've done, though, is just say how we can use skills with algebra to also work with trig functions. Okay, and sometimes that can come in handy in many cases. Okay, now let's try another different skill. Let's take a look at number 4. Let's say we have this. So in our numerator, we have 30 times sine cubed of x times cosine of x. And down here in the denominator, we have 6 times cosine squared of x times sine of x. Okay. Now, this example is mainly about just working with eliminating, making it simpler. Okay. So in this case, not really looking for identities so much, but look at what we cancel out. Everything's already in terms of sines and cosines. So look at our numbers. We have, of course, 30 over 6. Divide that, that's going to be 5 up top. Okay. Now let's take a look at the sine. We have over sine cubed of x means the sine of x cubed. Here's just one sine of x. What happens if I cancel one of these out, then essentially this becomes a 2. Okay. So we have sine squared of x. So basically I have 2 sines up here and 1 down here. One cancels, sorry, I have 3 up here, 1 down here. This one cancels out, so I have 2 left. And then in a similar way, we have a cosine here and a cosine squared down here. I can cancel this one out, and this base becomes a 1. So you have 2 cosines here and 1 here. 1 cancels out. And down here, I'm left with cosine of x. Okay. Now, there's one other thing we could do, which isn't entirely necessary. Let's write this out a different way. Let's write this as 5 times the sine of x. Of course, the sine squared means the sine of x times itself. Here we have cosine of x. Okay. Now what I'm going to do is I'm actually going to break this up. Let's say I want to get rid of the denominator. I didn't want any denominators. Okay. Let me say that up here. So here I want to get rid of the denominators. Now this is essentially an option. Notice I have to do this step, but we're going to do it here. Once again, just for practice. Denominator. Okay, so what I mean by break this up is I can think about multiplying fractions and multiply your numerators together, denominators together. So I can kind of put the cosine under any one of these three. So I'm going to write this like this. I'm going to write this as 5 times the sine of x over the cosine of x times the sine of x. Okay, if you see what I have here, then remember sine of x over cosine x is tangent. So this just becomes 5 times the tangent of x times the sine of x. Okay. Now, why is that simpler? You can see it's clearly simpler than what we started with. And actually, it's also a bit simpler than this because here we just have to calculate the tangent of x instead of doing sine and cosine as well. Okay. All right, let's do one more example. We'll start here. This will be number 5. Okay. Let's say we have this 1 plus cotangent of theta over cotangent of theta. Okay. Now, once again, we want to try and simplify this, and also trying to simplify is going to help us practice with some of our algebra skills involving trig functions. Now, here, if you look, our Pythagorean identities, we don't have anything for, these are just cotangents to the first power. Don't have anything for that. We do have some for cotangent squared, not just for cotangent. You know, this identity here is 1 plus cotangent squared, not 1 plus cotangent. So that one doesn't help us. So the best thing to do here, and also we can't really divide this all that easily. Well, actually, the easiest thing to do here, which I just realized I plan to do it another way. Actually, this is the quickest way. Okay, the quickest thing to do here is just separate this. By separate, I mean put both over the denominator of cotangent. So we have 1 over cotangent of theta plus then cotangent of theta over itself. Okay. And obviously cotangent over itself is just 1. Now, what is 1 over cotangent? Well, let's go back to the very top. Where we said that cotangent is 1 over tangent, and this goes both ways. So they're reciprocals of each other, so tangent is in 1 over cotangent. And so this is just the tangent of theta. And so this whole thing is just the tangent of theta plus 1. Okay? And that's a much easier expression to work with than that. Okay? So what we've done today is just kind of start the beginning of working on simplifying trig expressions. What we've seen is how we can basically use the skills we already know, adding, subtracting, multiplying, dividing, and also factoring. I should probably include that over here. So let me actually update this. Divide and factor. You get a simpler expressions. We're going to practice with those. And then we also put things in terms of sines and cosines, use them the basic identities we had, and also use the Pythagorean identities we had just a bit to help us actually work with simplifying. And this is just the beginning of a process. So the more you work with trig expressions, the more you try to simplify them, the better you get at it. And also the quicker you can recognize what the best approach is. Thank you. Have a good day.